Hey everybody, Mr. Reeves back with you again today. And today we're looking at proportional relationships and different ways to represent proportional relationships. All right, so let's start off by talking about what a proportional relationship is. A proportional relationship is a relationship between two quantities in which the ratio of one quantity to the other quantity is constant. All right, that sounds really complicated, doesn't it? All right, but remember when we were solving proportions and we were working with equivalent ratios? It's just that same idea, right? When you have a proportional relationship, that means one is a multiple of the other. One is a multiple of the other. That's probably the easiest way to look at it. So if you have two quantities, one we call x and the other we call y, that first one is x and that second one is y. And what we say is this: y equals kx, where k is the constant of proportionality. And again, that sounds really complicated, but it's really not that bad, okay? Let me just put it in words. Y is the second number. The second number is equal to a constant multiplied by the first number. Let me say that again. The second number is equal to a constant multiplied by the first number. All right, that's what a proportional relationship is. Again, where y is the first number, y is the second number, x is the first number, and k is a constant. So if you take a look here at the example in a book, it says Megan earns $12 an hour at her part-time job. Show that the relationship between the amount she earned and the number of hours she works is a proportional relationship. All right, so if you take a look at this table, we have the hours on the top and we have the amount earned on the bottom. So if I was going to go ahead and label these, right, I could call the number of hours x and the amount earned y, right? And if you take a look here, we've got 12 and 1, 24 and 2, 48 and 4, 96 and 8. And if I divide every time, if I did y divided by x, I get 12. Do you see that? 12, 12, 12, 12. So if I asked you what is the relationship, you could say that the amount earned is 12 times the number of hours. Or if we were going to write that as an equation, here it is right here. Y equals 12 over 1x, or y equals 12x. That is the proportional relationship. And that constant of proportionality, k, right? K is equal to 12 over 1, or 12, right? Every single one of them, that is 12, right? That is 12, that is 12, and that is 12. So again, to summarize, we would say that the relationship between the amount that she earned and the number of hours she works is a proportional relationship. And by the way, these would all be called what kind of ratios? Equivalent ratios, right? And if I put any two of those equivalent ratios equal to each other, what would I have? I would have a proportion, right? 48 over 4 equals 96 over 8. Those are equivalent ratios. So therefore, they form a proportion, right? So a proportional relationship, it's just a whole bunch of equivalent ratios set equal to each other, only it would go on forever and ever and ever and ever, right? Because x could be anything, and x times 12 will always be y. So there's infinitely many. It's kind of like creating infinitely many equivalent ratios. Infinitely many equivalent ratios, or we could create infinitely many proportions out of it, right? All right, so it says 15 bicycles are produced each hour at the Speedy bike works. Show that the relationship between the number of bikes produced and the number of hours is a proportional relationship. All right, so if we were to make a table, all right, and on the top we put number of hours, right? Let me extend that there. And if on the bottom we put number of bicycles, okay, and then we made this table and filled it out, okay. Well, if they work 0 hours, then they would produce 0 bicycles, right? If they produced one hour, they would produce 15. 2, they would produce 30. 3, they would produce 45. 4, they would produce 60. 5, they would produce 75. 6, they would produce 90. And again, we could go on forever and ever and ever and ever, right? If we called the number of hours X and the number of bicycles Y, right? And if I said, what does Y divided by X equal each time? Well, I could do 15 over 1. By the way, we're not going to do 0 divided by 0 because you can't divide by 0. So we're going to start with the first one, right? 15 over 1, 30 over 2, 45 over 3, right? 60 over 4, and we can keep going all the way up. Every single time, what would those simplify down to? They would all simplify down to 15. So our constant of proportionality, right? K is equal to y divided by x. So we have a constant. Our y divided by x is always the same value. It's always 15. So our equation is going to be right what it says right here. There is our equation. When you have a constant of proportionality k in a proportional relationship, the equation will be y equals kx, or in this case, y equals 15x. Okay? So we've talked about what a proportional relationship is. We've looked at an example. We've looked here at a table and an equation. There's 3 different ways we represent proportional relationships: table, equation, and then the third way is a graph, right? Okay, so if we took a look at this graph right here, let's take a look and see, is this a proportional relationship? All right, remember, a graph is just a different way of showing a table. So if I were to make this table here, and I called this x and this y, remember this is the x-axis and this is the y-axis. Again, we have that 0, 0 right there. Do you guys agree that's 0, 0? Okay, and then what do we have? What are the points we have? We have 1, 3, and then we have 2, 6, and then we have 3, 9, right? And if we kept going, the next one would be 4, 12. It goes off our graph, so I probably shouldn't include it. But if I take each of those, if I do y divided by x, right? And again, we're not going to do 0 divided by 0 because we can't divide by 0. 3 divided by 1, 6 divided by 2, 9 divided by 3. What do we get every time? We get 3 over 1. So we have a proportional relationship where k is equal to 3, right? And we could write that as y equals 3x. So 3 different ways to represent this relationship. We have the graph right here, which we happen to start with this time. We have a table, and then we have the equation. So those are the 3 different ways we're going to look at representing proportional relationships, okay? And for each of those, we should see that the y value is 3 times the x value, whether it's in a table, whether it's on a graph, or whether you're using the equation. By the way, I said we're not going to divide 0 by 0, but if I put that 0 into an equation, does 0 equal 3 times 0? Does it? It does, right? 0 equals 0. So 0, 0 makes that equation true. We just don't write 0 over 0 equals 3 because it doesn't work that way. But it does make the equation true. All right, therefore it is part of that proportional relationship. Okay, so if you take a look at this one, I wanted to talk about this one because we need to remember that the y value does not always have to be greater than the x value. Okay, if you're comparing your weight on Earth to your weight on the moon, right? You weigh less on the moon because the force of gravity is less. You will float away. You will float away on the moon, where you would be solid on the ground on the Earth. So if you take a look at this relationship here, here is the table. Now, again, x is the larger number here. So this point right here is not 1, 6, it's 6, 1, right? And then the next one is 12, 2, right? And then we have 18, 3. And then this point over here is 30 and 5. Of course, they skipped one in between. If we were going up by 6, 6, 12, 18, they skipped 24, didn't they? They skipped that one right there. All right, 24, if we went, and this would be 1, 2, 3, 4. All right. Anyways, you don't have to have every value in the table or on the graph for that matter. That's why this line is there. It actually would go on forever and ever and ever. Okay, so remember, in a proportional relationship, right, k is equal to y divided by x. So a lot of times if I ask students off the bat, what is k in this, they tell me 6, which would make sense, right? Because 5 times 6 is 30, 3 times 6 is 18. But remember, it's y divided by x. So in this case, it's not 6, it's a 1/6, right? Because, excuse me, see? I always want to put the bigger number on the top. Because in this case, the bigger number is on the bottom. So k is 1/6, right? So here's our graph, here's our table, and our equation would be y equals 1/6 x, right? And the great thing, by the way, about the equation is now I can pick any value of x and find out what y is, right? So if I said a person on Earth weighs 300 pounds, how much would they weigh on the moon? Then I could put 300 in for x. I could put 1/6 in for my constant of proportionality, and I would find out that that person weighs only 50 pounds on the moon. Wow, that would be nice if you're used to walking around with 300 pounds and now you only have 50. Okay, so let's take a look here. It says the graph shows the relationship between the amount of time that a backpacker hikes and the distance traveled. Okay, so if we look at the time is on our x-axis and the distance is on our y-axis. So this point right here is 5, 6, right? This point right here is what, 10, 12? And this point right here is, what is this point right here? 15, 18, right? Okay. And we could also put these points in a table if we want to. We have the graph. I could put those in the table. I'm not going to. And then we're going to look for the equation that we have here. So this is x and this is y. Let's answer this question. What does the point 5, 6 represent? Well, x is the time and y is the distance. So it represents that the backpacker has traveled what? 6 hours in 5 miles, okay? Or hiked 6 miles in 5 hours, right? 5 hours to go, 6 miles. Okay, so what is our constant of proportionality? Remember, k is equal to y divided by x. So if I take one of these points, 6 over 5 equals 12 over 10 equals 18 over 15. They're all going to simplify to the same thing, aren't they? If they're all going to simplify to 6 over 5. All right, they all simplify to 6 over 5. So k is 6/5. So my equation is y equals kx. So y is equal to 6/5 x. All right. All right. So I hope that helps you understand what a proportional relationship is and how to represent that proportional relationship. We represent it as a table, we represent it as a graph, and we represent it as an equation where y is equal to kx. K is called the constant of proportionality. That is what you multiply the input by x to get the output by y. And if you want to find it, you simply do y divided by x. All right, until next time, have a good day.